Hello students, welcome to Mathbro. Today I am going to discuss some gunshot questions for your FA1 as well as for your midterm examination. So without delaying, let us begin the session. In this session, I am going to cover the topics relations and functions, inverse trigonometric functions, matrices, determinants, continuity and differentiability. This relations and functions I have kept in the last slide. So firstly, I will start with inverse trigonometric functions. See, the weightage is as follows. For relations and functions in PU boards, they will ask one question MCQ, 3 mark, one question, 5 mark, one question, total 9 marks. And from inverse trigonometric functions, one MCQ will be there, 2 mark, one question, 3 mark, one question, totally 6 marks. From matrices, MCQ one question, 3 mark, one question, 5 mark, one question, 9 mark, totally from matrices. Determinants, MCQ one question, 2 mark, one question from determinants, 5 mark, one question, 4 mark in part E. That part E is divided into 6 plus 4. That 4 mark is coming from this particular chapter, that is from determinants. So totally 12 marks from determinants in PU boards. Okay. So continuity and differentiability, this continuity itself carries 4 mark. Iದೇನು 4 mark ಐತಲ್ರಿ, ಈ 4 mark question part E ಒಳಗೆ ಬರುತ್ತೆ. So ಇವೆರಡು most important chapter for part E, right? So this is the second highest weightage carrying chapter in PU boards. Continuity and differentiability. 2 MCQs, 1 fill in the blanks, 2 mark 1 question, 3 mark 1 question, 5 mark 1 question and 4 mark 1 question, totally 17 marks. Okay, so we will start with inverse trigonometric functions followed by matrices and determinants, continuity, differentiability. At the end we will discuss about the relations and functions. So let us begin with inverse trigonometric functions. These are some 2 mark questions. I am not going to discuss any of the MCQs and 1 mark fill in the blank questions in this session. I will be discussing only 2 mark, 3 mark and 5 mark, that too gunshot questions. Means the questions which are asked in the previous year board examination, right? So this is the first question. We have to prove sin inverse of 2 times of x multiplied by under the root of 1 minus x square is equal to 2 sin inverse x, where x lies between minus 1 by root 2 to 1 by root 2. See, in case of inverse trigonometric functions, we need to be strong enough in trigonometric functions. Then only we are able to solve the questions in inverse trigonometric functions. Okay. So wherever we get under the root of 1 minus x square, we use substitution as x equals to either cos theta or x equals to sin theta. Remember this point. Yakantandre we know that sin square theta plus cos square theta is equal to 1, right? Cos square theta will be 1 minus sin square theta, then cos theta is equals to under the root of 1 minus sin square theta, or sin theta is equal to under the root of 1 minus cos square theta. For that reason we will use x as either cos theta or x as sin theta. So what I need to do is I need to substitute what? X as, if I take x as in the RHS part, he has given in terms of sin inverse. So I have to reduce this in terms of sin, right? So let me take x as sin theta. If you take x as sin theta, then that implies theta is equals to sin inverse x. Theta is equal to sin inverse x. So consider this. He has given that LHS as LHS is equals to sine inverse of 2 times of root of 1 minus x square equals, what I will write is sine inverse of 2 into x ಅಂದ್ರೆ ಏನಂತ ಹೇಳಿ ತಗೊಂಡಿದ್ರಿ sin theta, right? Then under the root of 1 minus sin square theta, close. Then sine inverse of 2 sin theta, what is under the root of 1 minus sin square theta? Cos theta. So we know that 2 sin theta cos theta is nothing but sin 2 theta. So sine inverse of this becomes sin 2 theta. Sine inverse of sin 2 theta will be, we have one property, that is sine inverse of sin x is equals to x, or else sine of sin inverse x is also x. So this is equals to 2 theta. 2 into what is theta? Theta is sine inverse of x. Hence we proved the RHS part, which is nothing but RHS. Therefore LHS equals to RHS. Hence we proved the result. Okay. And the next question. The solutions will be given in the description link of this video. Okay. Don't worry, I will be giving the solution for all these questions as a PDF format. Prove that, a second question is, prove that sine inverse of what? Sine inverse of 2x multiplied by 1 minus x square is equals to 2 cos inverse x. In this case, ಅಲ್ಲಿ ನೋಡ್ರಿ ಆಗ್ಲೇ ನಾವು x equals to sin theta substitution ಮಾಡಿದ್ವಿ, because the RHS part was in terms of sine. So ಇಲ್ಲಿ RHS ಏನೈತಿ? cos inverse ಐತಿ. What I should do is put x is equals to cos theta, right? If I put x as cos theta, then theta becomes equals to cos inverse of x. Then this becomes sine inverse of 2 into cos theta under the root of 1 minus sine square theta. Sine inverse of 2 cos theta under the root of 1 minus sine square theta is nothing but cos theta. Then what is 2 sin theta cos theta? Again sin 2 theta. So sine inverse of sine, that is 2 theta by property, right? So 2 theta is nothing but cos inverse x, which is equals to RHS. Therefore LHS equals to RHS. Hence we have proved the required result. Pause the video and note down the answer. The next question is for 2 mark. Prove that 3 sin inverse x equals sin inverse of 3x minus 4x cube. See, this is of the form 3 sin theta minus 4 sin cube theta. ನಿಮ್ಗೆ ಏನ್ ಅನ್ಸ್ಬೋದು ಅಂತಂದ್ರೆ, how will you come to know that ಇದು ಇದೇ ಫಾರ್ಮ್ ಐತಿ? How to use the substitution? For that, I in the beginning itself I have told you should be strong enough in trigonometric identities. Then only it is very easy to make the substitution, right? ಈಗ ಇದನ್ನ ನೋಡಿದ ಕೂಡಲೇ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಏನಂತೇಳಿ. 3 sin theta minus 4 sin cube theta is equals to sin 3 theta ಐತಿ ಅಂತ ಹೇಳಿ. So for that what I will do is, we will use x as sin theta. If you take x as sin theta, then theta is equals to sin inverse x. Theta is equals to sin inverse x. For this question, what I will do is I will consider RHS. So what is RHS? Sin inverse of 3x minus 4x cube, right? So sine inverse of 3 into, what is my x? Sine theta. 3 sine theta minus 4 sine cube theta. Sine inverse of 3 sine theta minus 4 sine cube theta is nothing but sine 3 theta. So sine inverse of sine 3 theta is nothing but 3 theta by property. So what is theta? Theta is sine inverse of x, which is nothing but LHS. Therefore, we have proved the result LHS equals to RHS, hence proved. Pause the video and note down the answer. Yes. Let's consider this question. He has given that 3, what I need to prove is 3 cos inverse x is equals to cos inverse of 4x cube minus 3x, and this is of the form 4 cos cube theta minus 3 cos theta, and that is nothing but cos 3 theta. So for that, what I will do is put x is equals to cos theta. Then that implies theta is equals to cos inverse x. So let me consider the RHS part. What is RHS? RHS is equals to cos inverse of 4x cube minus 3x. If I substitute in place of x as cos theta, then this becomes cos inverse of 4 cos cube theta minus 3 cos theta. Then cos inverse of 4 cos cube theta minus 3 cos theta is nothing but cos 3 theta. Right? Then cos inverse of cos is nothing but 3 theta, where theta is cos inverse of x, which is nothing but LHS. Thus, we have proved the result as LHS equals to RHS. There is no rule in mathematics saying that we have to always prove LHS equals to RHS. Namatra athara rules illa. We can prove as according to our convenience. Pause the video and note down the answer. So the next question is, prove that 2 sine inverse of 3 by 5 equals tan inverse of 24 by 7. For this, I will use the result 2 sine inverse of x equals sine inverse of 2x multiplied by root of 1 minus x square. Okay. So what is my LHS? LHS equals to 2 sine inverse of 3 by 5. Right. So 2 sine inverse of 3 by 5, in place of 3 by 5, if you take it as x, then if you apply that result, then it becomes what? Sine inverse of 2 into 3 by 5 under the root of 1 minus 3 by 5 square, which is equals to sine inverse of 2 into 3 by 5 is 6 by 5 multiplied by, this becomes 9 by 25, 25 minus 9 is 16, 16 by 25 under the root of 16 by 25 is nothing but 4 divided by 5, which is equals to sine inverse of 6 multiplied by 4 is 24, 5 into 5 is 25. So again, I need to convert this sine inverse in terms of tan inverse. For that, I will use one more standard result, that is sine inverse of x equals to sine inverse of x is equals to tan inverse of x divided by a root of 1 minus x square. Right. So if I use this, then what it becomes? tan inverse of x ಅಂತಂದ್ರೆ 24 divided by 25 whole divided by root of 1 minus 24 divided by 25 square, which is equals to tan inverse of 24 by 25 divided by under the root of 25 square is 625, 625 into 1 is 625 minus 24 square will be 576 whole divided by 625. Yes. Then what it becomes? That is equals to tan inverse of, let me write 24 by 25 as it is. Then if I simplify this, under the root of 625 minus 576, 625 minus 576 will be 49, right? This I will write it as 1 divided by under the root of 49 divided by 625. What is the root of 49? That is equals to 7. Tan inverse of 24 divided by 25 multiplied by denominator of denominator goes to the numerator. Root of 625 is 25 divided by root 49 is 7. So 25 and 25 get cancels. So we will get what? 24 divided by 7 as our RHS. Therefore LHS equals to RHS. Thus we have proved the result. Pause the video and note down the answer. Next question. That is for 2 mark. Again, write tan inverse of what? Root of 1 minus cos x divided by 1 plus cos x. Okay. For this I need to be very strong enough in trigonometric identities. Tan inverse of root of 1 minus cos x. So, ಈ 1 minus cos x ಎಲ್ಲಿಂದ ಬರೀತೀರಿ? We have cos 2x equals to 2 cos square x minus 1, right? If you take half angle formula, this becomes cos x is equals to 2 cos square x by 2 minus 1. ಈ minus 1 ಈ ಕಡೆ ತಗೊಂಬಂದ್ರ ಅಂತಂದ್ರೆ 1 plus cos x is equals to 2 cos square x by 2, right? ಇದು 2 cos square x by 2 ಆಗುತ್ತೆ. Then 1 minus cos x ಏನಾಗುತ್ತೆ ಹಂಗಾದ್ರೆ? 1 minus cos x is equals to 2 sin square x by 2. So if I substitute in place of 1 minus cos x as 2 sin square x by 2 and in place of 1 plus cos x as what? 2 cos square x by 2. Here 2 and 2 get cancels. So this becomes tan inverse of root of sin square theta divided by cos square theta is nothing but tan square theta. In place of theta we are having x by 2, right? Here square root and square get cancels. We have got tan inverse of tan of x by 2. So by property of inverse trigonometric functions, tan inverse of tan of anything is equals to what? X by 2, right? ಫಾರ್ ದಿಸ್ ನಾವು ಈಗೇನು ಇಲ್ಲೆಲ್ಲ ಸಾಲ್ವ್ ಮಾಡಿದೀವಲ್ಲ, ಇದಕ್ಕೆ ನಮಗೆ ಫೌಂಡೇಶನ್ ನಾಲೆಜ್ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. Then only we are able to solve the questions from inverse trigonometric functions. Pause the video and note down the answer. 2-mark question. One more 2-mark question. Find the value of sine of pi by 3 minus sine inverse of minus 1 by 2. Sine of pi by 3 minus sine inverse of this minus 1 by 2, I will write it as sine of what you say, pi by 6, right? Sine of pi by 6 is what? Andra sine 30 is nothing but 1 by 2. Then sine inverse of, if I write this minus sine theta as sine of, how will you write sine of minus theta? Minus sine theta, right? Minus pi by 4, minus pi by 6. Then sine of pi by 3, so minus pi by 6. Sine inverse of sine of theta is equals to theta. Then this becomes minus into minus plus pi by 6. What is 60 plus 30? 90 degree. Sine pi by 2, which is nothing but 1. 1 is the value of this particular question. Next question is for 3 mark. Write tan inverse of cos x minus sin x divided by cos x plus sin x in the simplest form where x lies between 0 to pi. See, if I divide this, outermost function tan inverse ಐತಿ, so I need to convert this in terms of tan. For that, what I will do is dividing both numerator and denominator by cos x. ಅವಾಗೇನಾಗುತ್ತಿದ್ದು tan inverse of cos x by cos x. Let me write it as cos x by cos x minus sin x by cos x divided by cos x by cos x plus sin x by cos x tan inverse of cos x get cancels, cos x get cancels. This becomes 1 minus sin x divided by cos x is tan x divided by 1 plus tan x. ಸರ್ ನಮ್ಗೆ ಇದಕ್ಕೆ ಯಾವುದು ಐಡೆಂಟಿಟಿ ಇಲ್ವಲ್ಲ, ಏನ್ ಮಾಡ್ಬೇಕೀಗ? ಎಸ್, ಒಂದ್ ಸ್ವಲ್ಪ ನಾವು ಯೋಚನೆ ಮಾಡ್ಬೇಕಿಲ್ಲಿ. ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ 1 I will write it as tan pi by 4 because tan 45 is 1, ಗೊತ್ತೈತಲ್ಲ ನಮ್ಗೆ ವ್ಯಾಲ್ಯೂ, minus tan x divided by 1 plus ಇಲ್ಲಿ ಏನೂ ಇರಲಿಲ್ಲಪ್ಪ ಅಂತಂದ್ರೆ 1 ಇರುತ್ತೆ. Let me write it as tan pi by 4 multiplied by tan x, and this is of the form tan a minus tan b divided by 1 plus tan a into tan b, which is nothing but tan of a minus b. So therefore that is equals to tan inverse of tan of pi by 4 minus what? X. So tan inverse of tan is, that is nothing but innermost variable, that is pi by 4 minus x is our answer. Pause the video and note down the answer. So the next 3 mark question is prove that cos inverse of 12 by 13 plus sine inverse of 3 by 5 equals to sine inverse of 56 by 65. So this is most important question. So let me consider this cos inverse of 12 by 13 as A and sine inverse of 3 by 5 as P, and this is equals to sine inverse of 56 by 65. Okay, if I take this sine inverse to left side, then it becomes sine of A plus B equals to 56 by 65. Let me consider this as equation number 1. In this equation, I need to find sine of A plus B. So we know that sine of A plus B is equals to sine A cos B plus cos A sine B. For that, I need to find what? Sine of A, sine of B, cos of A, cos of B. Okay. For that, what I will do is A equals to cos inverse of 12 by 13. Then cos A becomes 12 by 13. Draw the triangle, right angled triangle. This is adjacent divided by hypotenuse. 12, 13, 5. Okay. These are the Pythagorean triplets. So sin A will be 5 over 13. Then if you consider B equals to sine inverse of 3 by 5, draw the right angle triangle. Then sin B will be equals to what? Sin B will be equals to 3 by 5. Opposite divided by hypotenuse 3 by 5. And this becomes 4. So cos B becomes what? Cos B becomes adjacent divided by hypotenuse. That is nothing but 4 by 5. So substituting these values in the expansion of sine of A plus B. So consider sine of A plus B equals to sine of A plus B is equals to sine A cos B plus cos A sin B. So sine A, what is the value of sine A? That is 5 by 13. What is the value of cos B? Cos B is 4 by 5 plus cos A value is 12 by 13 and the value of sine B is 3 by 5. So 13 5s are 65. 13 5s are 65. 13 5s are 65. 65 becomes the LCM. 5 4s are 20 plus 12 3s are 36, and this becomes 56 divided by 65. This is what I need to prove. Sine of A plus B is equals to 56 divided by 65. If I substitute this value sine of A plus B in the equation number 1, then it becomes LHS equals to RHS. From 1, or else from 1, if you substitute sine of A plus B as 56 by 65, then 56 by 65 equals to 56 by 65. So thus we have proved the required result. LHS equals to RHS. That's it. Pause the video and note down the answer. One more 3-mark question which is of the similar kind. Prove that sine inverse of 8 by 17. Sine inverse of 8 by 17. Let me consider sine inverse of 8 by 17 as A again, and sine inverse of 3 by 5 as B, equals to tan inverse of 77 by 36. If I shift the tan to this side, this becomes tan of a plus b equals to 77 divided by 36. Okay, let me consider this equation as 1. So again, what I have taken is sine inverse of a equals to sine inverse of 8 divided by 17. Then sine a becomes 8 by 17. If you draw the triangle, right angle triangle, opposite is 8, opposite will be 8. If I draw the right angle triangle, then opposite is 8, hypotenuse will be 17 and this will become 15. So if I need to convert this sine a in terms of tan a. So then tan a will be equals to opposite divided by adjacent, that is 8 by 15. The next, b equals to sine inverse of 3 by 5. Then sine b equals to 3 by 5. If you draw the triangle, this will become 3, this will become 5, and obviously this will be 4. So tan b equals to what? Tan b equals to opposite by adjacent, 3 by 4. So let me expand this. Tan of a plus b is tan a plus tan b divided by 1 minus tan a into tan b, which is equals to 77 divided by 36. So substituting the values for tan a, tan b, what is the value of tan a? 8 by 15 plus tan b is 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. That is equals to 7 by 36. 15 fours are 60. Then this I will write it as, let me write it here. 8 fours are 32. 32 plus, then 4 15s are 15 3s are 45 divided by 15 4s are 60 whole divided by 15 4s are 60, 60 minus 8 3s are 24 whole divided by 60. This must be equals to 77 divided by 36. Check ಮಾಡೋಣಂತೆ, ಇದು 77 by 36 ಬರುತ್ತೋ ಇಲ್ಲೋ ಅಂತ. 60 get cancels. 32 plus 45 will be 77 divided by 60 minus 24 is 36. 77 divided by 36. Thus we have proved the result as LHS equals to RHS. Pause the video and note down the answer. Next question is also of 3 marks. This question, the same question, you will be using the foundation knowledge in case of differentiability, right? So what I need to prove is LHS equals to cot inverse of root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x cot inverse of rationalizing the denominator. What is the conjugate of denominator? If I take this as root of a minus root of b, root of a minus root of b, the conjugate ಏನಾಗುತ್ತೆ root of a plus root of b ಆಗುತ್ತೆ. Multiplying and dividing by what? Root of 1 plus sin x plus root of 1 minus sin x. Then root of 1 plus sin x plus root of 1 minus sin x into root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x multiplied by root of 1 plus sin x plus root of 1 minus sin x. So this becomes cot inverse of, this is of the form a plus b into a plus b, a plus b whole square, right? Where a is nothing but 1 plus root of 1 plus sin x plus root of 1 minus sin x whole square divided by, this is of the form a minus b into a plus b. Then this becomes what? Root of 1 plus a square minus b square, right? A plus b into a minus b square minus root of 1 minus sin x whole square. This I will further write it as cot inverse of a plus b whole square is a square plus b square plus 2 times of ab, right? So this becomes 1 plus sin x, root of 1 plus sin x whole square is 1 plus sin x, 1 plus sin x, and root of 1 minus sin x is, sin x whole square is 1 minus sin x plus 2 into a into b. This I will write it as 2 into under the root of a plus b into a minus b is a square minus b square. So that becomes 2 root of what? 1 minus sin square x, 1 minus sin square x, right? Divided by a plus b minus of a minus b ಅಂತಂದ್ರೆ ಇದೇನಾಗುತ್ತೆ ನೋಡ್ರಿ, 1 plus sin x, 1 plus sin x minus 1, minus of minus will be plus sin x. Here plus 1 and minus 1 get cancels, plus sin x and minus sin x get cancels. So what it becomes is cot inverse of 1 plus 1 is 2. Let me take 2 common from the numerator. 2 into 1 plus under the root of 1 minus sin square x will be cos x divided by sin x plus sin x is 2 sin x. 2 get cancels again. See, 1 plus cos x, we know that cos 2x or cos x is equals to 2 cos square x minus 1, 2 cos square x by 2 minus 1. If I bring this minus 1 to this side, left side, then it becomes 1 plus cos x equals to 2 cos square x by 2. Correct? So in place of 1 plus cos x, let me write it as 2 cos square x by 2 divided by sin x plus sin x is 2 sin x, and this sin x can be written as 2 sin x by 2 into cos x by 2, half angle formula. 2 sin x by 2 into cos of x by 2. 2 get cancels. 1 cos x by 2 from the numerator and cos x by 2 from the denominator get cancels. Sorry, I have forgotten to write the cot inverse of this. Okay, so cot inverse of cos x by 2 divided by sin x by 2 will be cot x by 2. So by property we can write it as what? Cot inverse of cot is equals to x by 2, which is nothing but RHS. Hence we have proved LHS equals to RHS.